Hello there! As promised this week, I will attempt to solve a few lab problems as to show you what goes through my mind when thinking about and approaching a programming task. Hopefully by the end of the video, you'll get some insight as to how to best tackle programming problems in general. Now, I'll be picking up one problem from each lab, starting from the third one, and let's just start off with 3.14 from lab number 3. The problem tells us that we should input sex, height, and age, and then the program should calculate the ideal weight of a person using this formula. I already have a short thingy created, a program created, and I will need 3 variables, as I can see here. I will need the sex, the height in centimeters, and the age. Now, I'm gonna assume that the sex can be read as a character, so it will be a char. And then the age and the height could just be integers, age and height. Great. Now, I always like printing out a short description of what I'm about to read. So for reading the sex, I will just print F, please enter the sex, and a new line, and then I will scanf a character, and that's going to be the sex. Now, as to make things a bit more clear, I would like to make sure that the sex is properly chosen, because I'm going to need either a male or a female. If it's anything else, I know it might be a bit politically incorrect, but if it's anything else, then I wouldn't be able to calculate this formula based on the sex. So I will make an if sex is either a male or sex is equal to F, which indicates a female, then I will move forward. And if not, else, I should printf something like this. Sex is not properly chosen. Please rerun the program. Let's leave it at this for now, and we can come back a bit later and see how we could actually make the user choose the correct sex, either male or female, and not close the program. But until then, let's move forward. So if the sex was properly chosen, then we should pick the age now, and again, printf. Please enter the age, a new line, and scanf. I'm going to need an integer, and I'm going to use the age variable. And then again, I would like this age to be positive. I don't care how old the person is, but I would like the age to be positive. So I'm going to make sure that the user picked a positive integer. If age is bigger than 0, then I move forward. Else I printf. Instead of sex is not properly chosen, I will pick age is not properly chosen. It was negative. Please rerun the program. And we'll come back to this as well. And if age is properly chosen, then we should pick the height. And I'm going to copy this and this. There we go. Please enter the height. And scanf %d. And height. Now again, the height should be positive, so I'm gonna, if height is bigger than 0, then I will move forward. Else I'm gonna printf that the height is not properly chosen. Height is not properly chosen. It was negative. Please rerun the program. Okay, and then here I will just do a small test indicating that the sex was equal to this, and the age was equal to this, and the height was equal to this, and I'm gonna put age, actually sex, age, and height. There we go. Okay, so let's run the program, not before formatting the code. Much prettier, thank you. And then compiling it and then running. Okay, so the age, enter the sex, and I will put F, enter the age, maybe 20, and the height, I don't know, 150. Okay, and the sex was F, the age was 20, and the height was 150. Okay, so the data is being read. Okay, I don't need this for now, but I will need this. So the formula says that if the sex is male, then the ideal weight should be 50 plus 0.75 times height minus 150 plus age minus 20 divided by 4. Now let's have a different variable here, and this would be, I think, a float, maybe. Yes, float ideal weight equals to 0.0. I will initialize it, and then I will see on whether or not I'm dealing with a male or a female. If sex equals to male, I will do some calculations, else, and I can write else here without else if, because I am sure, because of this thing here, that sex is either male or female. So else suffices here. Now, the ideal weight calculation formula for a male is simply this one, 50 plus 0.75 times height minus 150 plus age minus 20 divided by 4. And the ideal weight for a female, much simpler, ideal weight equals to the ideal weight of the male minus 10. Interesting. All right, so then I need this anyways, and I can actually put it outside. So I'm calculating the ideal weight of the male regardless of whether or not the sex chosen is M or F, male or female, because if it is a female, then I will need it anyways, and if it's not, then it's just that value. So sex, I'm gonna change this to F and move this here and put the ideal weight equals to the ideal weight minus 10. Okay, so I'm formatting the code and then printing out the following message. The ideal weight is %d new line and ideal weight. Great. So let's check if it works. Okay. Oh, right. So the ideal weight is actually a float, and I am trying to print out an integer. This should be F, not D. Again, compiling, no warnings, no errors. Let's try it out. Alrighty, so please enter the sex. It's going to be M this time. The age is, I don't know, 43, and the height is 180 centimeters. The ideal weight, apparently, for a 43-year-old, 180 centimeters height male is 77.5 kilograms. I don't like so many zeros at the end, so I will put a %.d here and rerun the whole thing. Alrighty, and okay, let's check male again, and maybe 15, and height 190 at tall. Okay, what did I forget? Oh, right, it's yeah, this should be in front of the F, and putting it again, M, 18, height, whatever, 120, short guy, 27.5. Okay, so this is the basic way of solving this problem. That's about it. This is all you were asked to do in the problem, and but there are things which can be done a bit better. What if I want to trap the user into picking a correct sex, a correct height, or a correct age? I don't want the program to exit whenever a user doesn't pick the right age, or a negative age, for example, but I want to trap the user there. So what do I do if I want to do that? Well, there are a few changes which I want to make. First of all, I need a while loop. Something like this. So while the user didn't pick one of the two options, then I will ask the user to pick, user to pick again. So this is in my mind, this is what I need. Let's translate all this to actual code. Now, I would like to have a function which reads this sex. And I know we're treading into the next lab's problems, but I think you'll do fine. So what if I had a function which reads a character and returns a character, and let's name that function read sex. And now I will actually need this character here. Let's name it sex, and then I want to read it. Okay, and actually return it afterwards. And I think that for this get ch, I will actually need, oh, what? Okay, so let's erase that for now. Okay, implicit declaration of get ch. I think I need to include conio. Okay, let's see. Great, now I'm fine. And I need this get ch instead of scanf because, well, scanf will cause some issues because of how it reads characters and ulines and stuff like that. Just trust me, let's use ch. We should have used that from the beginning, but nevertheless. Okay, and also I would like to move this here because whenever I execute this function, I need the user to know that I expect of him to input this x. And so first off, I will call this function and say something like this. Sex equals to read sex. Okay, great. Now, while sex is not male and sex is not female, then sex should be read sex again. And after this, I will be sure that the user printed out a correct sex and inputted actually the correct sex. And here I will actually need to print a message, printf, and no, I'll just copy it from here actually. There we go. And I won't need this else. And I won't need this if actually, because I've already made sure that it's a fine value. Okay, reformatted the code and now it looks something like this. So first off, I read an input value, either, well, M or F, hopefully. And while that value is not M or F, I ask the user to input it again. Let's see how this works. I compile, everything's fine. Please enter the sex. So I put L. Sex is not properly chosen, please. Okay, I forgot this. Now, because I'm not using a scanf, you won't be able to see what I'm inputting, but I'm inputting something like Q or W or P or L or M. Finally, I have put M, and now I am picking the age. Okay. Let's do the same thing for age and the same thing for height. So I'll need a function, something like char read integer. And I will need something like this. What should I name it? Type. And you'll see what I'm about to do. Here I need an integer, so value, and I will be able to use scanf here, I think. Let's see, and input the value, and before all this I want to print a message stating that, hey, I want to read something. Okay, so printf. Here I want to have please enter the %s, and here type, and a new line afterwards. Okay, and then return value. Oh, and I need this to be an integer, not a character. Great. So let's try this out. This is actually gonna be a string, a character string. And I want the age to be read integer, and the type should be age, a lowercase letter. So let's see how this behaves. I'm about to enter a female, enter the age, and voila, it actually says age here. And this is because of this function. Great. And while age is smaller than 0, smaller than or equal to 0 actually, I will printf age is not properly chosen. Please choose a positive age. And then age equals to read integer of age. Okay. Now at this point of the program, I will be sure that I have both a correct sex or a correct age. I won't need this anymore, neither will I need this, and also I can delete this. Format, again, great. Let's do the same thing for height. And I'm going to read height. Height equals to read integer of height. And this string over here, this type, will simply be appended to this string over here. And basically, if I want to read the age or the height, I won't need a different function. I will just need to put a different string here. And while height is smaller than or equal to 0, I will printf this thing here, but a bit changed. Height is not properly chosen. Please choose a positive height and ask for it again. Height equals to read integer of height. Great. And then I won't need this and I won't need this. Okay, well, our code actually looks a lot better, I would say, because the cyclomatic complexity is now very, very small. And what I mean by that is, well, when you have a lot of ifs inside of ifs, inside of ifs, inside of switches and stuff like that, then that will increase something called the cyclomatic complexity. That will actually make the code a lot harder to read. And it may not seem this way from such a small program, but trust me, it really does. So let's run this thing, and I'm choosing wrong sex, and I'm finally choosing M. Okay, now I have to input the age, and let's choose -4. Age is not properly chosen. Please choose a positive age. Okay, so I'm choosing 25. And again, let's try this out for height, -200. Height is not properly chosen. Let's choose something like 190. And then finally, the ideal weight is 81 kilograms. And I maybe should put kilograms here. Okay, and well, that's about it. I think we can do a bit better though with these things. I see a lot of duplicate code here. While age is smaller than 0, height is smaller than 0. Could it be that we can actually make this better? And I really think we could. Maybe it's an overkill, but maybe not. So let's try out and, try to put all this in a function such that we don't have a lot of duplicate code. Maybe it would be nice to have something like read positive integer. And I would need the type again. And in here, I would put something like this. Well, I would need the integer to be read, so value. And I will put something like this. While value is smaller than or equal to 0. And first I need to read it. So value equals to read integer of type. And while value is smaller than 0, I will put something like this. Printf. My string, which is going to be the type, is not properly chosen. Please choose a positive type again. And here it's going to be type. And value equals to read integer of type. And finally, I will return value. And now, instead of age equals to read integer, I will have age equals to read positive integer of age. and then I can remove all this. And height equals to read positive integer of height, and I can remove all this. Great! I have just removed like 5 lines of code, which is nice. Let's try it out. I'm compiling, no errors. So enter a sex, I will choose M, and the age is 20, let's minus 25. Age is not properly chosen, please choose a positive age. What am I missing here? Did I do something wrong? Please enter the, oh yes, I actually forgot about this new line here. Let's do it again. So age is M, sex is M, and then age is minus 25. Age is not properly chosen, please choose a positive age. And then it prompts me to choose age again, and I pick 25, and the height is minus 100. Again, height is not properly chosen, and then I choose the height of 170, why not? The ideal weight is suddenly 66 kilograms, and I think that's it. No, actually not. It's not it. I like to keep my main function very, very clean. So what I'm gonna do is move all this ideal weight calculation to another function. So let's just put this ideal weight and equals not to 0.0 but to compute ideal weight. And this is a function which I have not created yet, as you can see, and it is a function which will take as parameters the sex, the age, and the height. Great. So I already know what this function should return. It should return a float, and I already know what this function should take as parameters. It should take a character and 2 integers. So let's write that function down. Float, compute ideal weight, and then character sex, and then integer age, and then integer height. Now I'm not gonna put, I'm just gonna copy this thing from here into here. There we go. So float ideal weight equals to 50 plus all that. I have the height, I have the age, and then I just need to return ideal weight. Okay, and I format my code and compile, and there's no errors, so everything's fine. Good. Now let's make sure it works. I'm choosing a male of age 28 and of height 186, and the ideal weight is 79 kilograms. Great. Well, this is quite an improvement from how it looked before. And I challenge you to just look back on how the code looked in the beginning and see how it looks right now. One more thing which I like doing is actually moving these functions to a different file. So what I want to do is move all these functions to a different file just to have everything very nice and very clean. And I do this by file, new empty file, yes, and I actually want to make it a header file. So let's just name it head.h and save it. Yes, okay, I have a header file. And I also want to make, so Control-Shift-N, another file, which is going to be my functions.c. Okay. And in functions.c, I will need to copy all this code, actually cut it and save, and functions, there we go. Okay, and in header, in head.h, I will just need the headers of the functions. So I'm copying this, I'm copying this, I'm copying this, and I'm copying this. Great, and I'm saving, and in main I can just include head.h, and the linker will work. Okay, what am I? Okay, so here I need to include these two things. Okay, implicit. Okay, actually, I need this as well. There we go. That's fine. I'm going to compile main and also fine. Let's check it if it works. I'm choosing a female of age 22, a height 160, and the ideal weight apparently, according to this, is 47.5. Okay. Now, well, that's about it. I could be moving this to a different function as well, but maybe that would be a bit of an overkill. However, just to make things a bit more pretty, actually, no, I'm gonna make this read sex function actually force it to read a proper sex, and I'm gonna be trapping this into the while. And actually, this should be here. Okay, let's compile and make sure everything's fine. Yes, it should be. I'm running. Please enter the sex. I'm putting something like I. Okay, I'm missing something. I'm missing this. Actually. Okay. And I'm putting something like Q, O, P, and finally F. Now it's fine. Age 29, height 190, it doesn't matter. Ideal weight 72. Okay, great. And now this is the final function, the final main function, and it kind of looks good. It looks clean. And if I want to know how read sex works, I just go here and check that out. And if I want to know how these things work, I just check them out here. And well, it just looks clean. This is my definition of how a clean function should look like. Not a lot of code, not a lot of ifs, not a lot of whiles, just, you know, one level of indentation. That's perfect. And yeah, that's about it for this problem, and let's move to the next one. Alrighty, so let's try out a new one. I created a test problem 2 already, and this time we will be doing problem 18 from lab 4. So given a natural number n, find the number obtained by eliminating those digits that appear more than once, and then b, find the number obtained by switching the first with the last digit, the second with the next one, and so on, basically just reversing the number, and then find the biggest number that could be obtained by a combination of its digits. That's fine. Okay, seems easy enough. Alrighty, so the first requirement is to find the number obtained by eliminating those digits that appear more than once. So for something like 112543116, I should be getting, whoops, what the hell? There we go. I should be getting something like 125436, right? Yes, so everything is just once. Okay. Now, how do we work around this? Well, I think I will want an apparition vector. And what that is a vector that for each position starting from 0 to 9 will indicate whether or not that digit appears in my number. So for example, for this number 112543116, initially my vector will be something like 0, 0, 0, 0, 0, 0. I don't know how many zeros I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and I need one more, 10, because I have 10 digits from 0 to 9. So for this number in particular, I will have something like this. So 1 appears in the number, 2 appears in the number, also 3 appears in the number, and so does 4, 5, and 6. However, 0 doesn't appear, and neither does 7, 8, or 9. If I were to have something like, instead of 5, I would have, well, I wouldn't have 5. I would then have 0, 1, 2, 3, 4, 5, and this would be 0 because 5 never appears. And maybe I would have a 6 or 7 at the end, and then this would be 1. So this is an apparition vector. If whether or not the digit appears in the number. So I'll need something like a function which returns that apparition vector, but until then, let's just try out and input our number. So print, actually long, I'll be using a long value instead of an integer because I want those numbers to be long enough. So long n, and then printf, please insert n, and I'll put it like that, and scanf, and LD I think is the way to go, and address of n. Great. So now I have my number n, and somehow I need to return that apparition vector. Now, a function in C will never be able to return a vector, so I'll be needing a pointer. So int pointer apparition vector, and equals to get apparition vector, vector of n. And now I'll need to create this function, get apparition vector, which returns a pointer, and it takes as an argument, as a parameter, a long number n. Now let's allocate this dynamically. So int star apparition vector, what am I writing, equals to malloc size of int times 10. And well, I'm writing this 10 here because, well, in base 10, which we are working in, there are only 10 digits. So while n different from 0, so I have to iterate through this number and then return finally the apparition vector. So while n is different from 0, fetch the first digit, so digit equals to n modulo 10, and then make sure we make n smaller, so n is equal to n divided by 10. I know there's a short way of writing this, but I prefer it this way for now at least. And apparition vector of digit equals to 1. Okay, so now at the end of all this, the apparition vector should contain 1 if that number, which I inputted here, the n, contained that digit at that position. So, okay, unused variable, I know. So what now? What am I going to do with this apparition vector? So the requirements says that I should obtain the number by eliminating those digits that appear more than once. Great. So I now know which digits appeared. But I want to make sure that I form the number from the previous one such that no digits are duplicate and should start from the beginning. So, all right, let's see how we do that. So first of all, I think we will need to iterate through that n again, but I actually want a function for this. So a long, which is, how should we name this? Distinct digits equals to get distinct digits, and this should be based on n. Okay, so let's create a function called long distinct digits. It returns a long, and it accepts a long as a parameter, long n. Now, I know I calculated and computed this apparition vector here, but it's actually not needed here. I'll need it in this function because this is where I'll be using that apparition vector. Okay, so let's just scroll through the digits of n. So while n different from 0, what should I be doing here? Well, well, I'm going to first fetch the digit. So int digit equals to n modulo 10. And then I should be writing something like this. If apparition vector of digit equals to 1, then first of all, well, then I should be adding something to another number just to form it. And let's name that number new n. So actually, I got a better name, long distinct n. And it should start from 0. And that distinct n should be something like this: plus equals to this, equals to distinct n times 10 plus digit. Am I doing this right? Plus digit? Yes, plus digit. Okay. And then furthermore, we have to make sure that this digit doesn't get counted again. So apparition vector of digit should be now equal to 0. Okay, and then n becomes and should become n equals to n divided by 10. And in the end, we return distinct n. And we format our code. Now it looks a lot better. And let's see what we obtain from all this. Let's printf %ld. Actually, so for a, the number obtained by eliminating duplicate digits is this one, and in the end it will be distinct digits. Let's see what we have. Okay, no errors. So 1 2 3 4 3 2 3 5 4 5 1. So the result from this should be 1 2 3 4 5, and that's it. But it's actually something negative. Great. I'm doing something wrong. What am I doing wrong? I think I know what I'm doing wrong. Well, first of all, I think that the number is too large. Let's try something a bit smaller. 1 2 3 2 6 2 6 4. And the number obtained should be 1 2 3 6 4. But it's actually 4 6 2 3 1. Interesting. What is going on there? Okay, I know what's going on. While I'm iterating through number n here, the first digit to pop up will actually be 4, the one at the end. And I'm scrolling from the other end, not from the beginning. Well, this will cause issues because the number which I want to form should be formed from this side, not from this one. So I need to make sure that I actually iterate through n from the other side. And for this, I want to reverse n, actually. So instead of going through n like this here, I should be going through the reversal of n. So long reverse n equals to get reverse of long of actually number n. So I need another function called get reverse of number, which will return a long and accept a long as a parameter. Now, how do I do that reversal? Well, it's quite simple, and it's very, very similar to these things. So first of all, I'll need a reverse number, which starts off from 0 and and while n is different from 0, once again, I fetch it. I don't even need to fetch a digit, actually. Reverse number equals to reverse number times 10 plus n modulo 10, and then n becomes n divided by 10, and then return reverse number. I hope I'm doing this right. Let's format the code. And first off, let's printf reverse. I should be just debugging this, I know. Reverse n, and just make sure that this is fine. Okay. So n is 1 2 3 4 3 2. Okay, the reverse is 2 3 4 3 2 1, which is nice. And then the number obtained by eliminating the duplicate digits is 2 3 4 1. Okay, this shouldn't work, so it doesn't. And I actually have to change this thing here. So instead of n, I should be putting reverse n, and this should be reverse n. And what else? and reverse n equals to reverse n divided by 10. Alrighty. So let's check this again. 1, 1, 1, 2, 2, 3, 1, 1, 1, 2, 4, 3, 4, 2, 1, 6, 4. And the result should be 1, 2, 4, 3, and 6. Oh wait, what? The number obtained is 0? Why is it 0? No. I'm doing something wrong again. What am I missing? Actually, let's just try this again. I think I wasn't missing anything. So 1, 1, 2, 3, 2, 1, 4, 1. That's fine. Now it works. I think the number was just too long. Yeah. Alrighty. So this should be the result. Let's check out another number just to make sure that it's fine. So I'm picking 6, 4, 1, 6, 2, 4, 6, 8. And the number obtained should be 6, 4, 1, 2, 8. What? Okay. 6, 4, 1, 2, 8. There we go. We're fine. We got this. Okay, so this was part A, and we wrote quite a few different functions, but our main method looks amazingly clean. Now for part B, we should find the number obtained by switching the first digit with the last one, the second with the next, and so on. Well, what a surprise. We've actually done this already. This is done by simply reversing the number, and we have this get reverse of number function, which is, well, exactly what we need. Look at what we can do more. Instead of making this variable, because we're not going to be using it again, we're just going to be calling this function here. So why not do the same thing for part B, which is the, how do we call it? Yeah, the reversal of the number n is, and then a long decimal, get reverse of number n. And let's see if it works. Should work. 1, 2, 3, 1, 2, 4, 1, 6, 3. And then the reversal is 3, 6, 1, 4, 2, 1. And of course, this should be working as well. And it does. Good. So we've done part 1, part 2, and now we're off to part 3, which is getting the biggest number that could be obtained by a combination of its digits. Let's just keep this format and printf, see the biggest number from the digits is, and then another long with a new line, get biggest number, and we're going to be passing an n, which is a long, and so we make another function, long get biggest number, long n as a parameter. Please don't hate me because I'm writing such short values for the such short names for the variables. Okay, so biggest number by digits, how do we work around that? Well, I think it would be very helpful to have an apparition vector. This way we can count how many times a number appeared, and then basically we would just iterate through that apparition vector from the end to the beginning and form the number like that. So let's just say we would have the number 1, 2, 9, 5, 4, 4, 9. The biggest number we can form from these digits is basically 9, 9, 5, 4, 4, 2, 1. Yes, so we order all the digits. So an intermediary step would be something like this, ordering 1, 2, 5, 4, 4, 5, 9, 9, and then just taking this in reverse. Okay, so how do we do that? Let's just use an apparition vector. Actually a frequency vector. Did I say apparition vector? I meant frequency vector. So int, we need another function, of course, int frequency vector equals to get frequency vector from n, and we need another function, int star frequency vector. It accepts a long n. So how long should this be? Again, it should be as long as the apparition vector. So we're just gonna copy this code here, and instead of apparition vector, we'll name it frequency vector. Great, inspired. And also we can copy this code, but instead of having this apparition vector, we'll have the frequency one, and instead of putting just one here, we will put a plus equals 1, or why not just plus. But now we have to make sure that it's initialized. So why not memset frequency vector, I think it's 0 and then 10, I hope. Let me just quickly check this. Yeah, this should be fine. This should work. Okay, so now this frequency vector will basically contain 0 if that digit at that index was never in the number, and then it should contain the number of apparitions of each digit. Okay, so we have a frequency vector. Now let's try to form our number. So long n, long biggest number equals to 0, and we'll form our number based on this frequency vector. How do we do that? First off, we need to iterate through our frequency vector, and we know that it's of size 10. So we're gonna be doing a for loop. So for int I equals to 9, because we want it to go backwards, and I bigger than or equal to 0 and I minus minus. So the easy way out would be just to print. So let's just see if we have the correct data inside. So while frequency vector of I is different from 0, let's just printf the digit from there. So it's frequency vector of I. No, actually we just need I, and then frequency vector of I should be minus decrement, and for now we are returning biggest number. We haven't calculated it yet, but this should print out our number just fine. Let's just test this out for now. Okay, what am I doing wrong? Undefined reference. Undefined reference. What? Oh, okay. I'm missing that. Okay, implicit declaration of memset. Where did this memset? It's from string.h, isn't it? It is. Include string or strings. It's string. I think it's string.h. Yes, great. Now let's see what we have here. So our example was something like this. Yes, goody. Yes, it does work. It works just fine. But now let's just put it in a number. So instead of this, we would need something like biggest number equals to biggest number times 10 plus I. And then I needed this back. Crap. See, the biggest number formed from those digits is, and a long, and then get biggest. Actually, I have this here. Ta-da! Okay. Okay, compiling fine. So 194295555. Yup. This looks about right. Yep. All right. So, I think we're done with this problem as well. If you guys want to move these functions in a separate file, then do so. You know how to do that. The main function looks fine. It's clean. It has like a few lines of code. And yeah, that's about it. I mean, I could move this into another function and have something like equals to read long, but I mean, come on, it's really not that necessary. Okay, so let's go to the next one. All right, so the next lab is actually functions, the lab number 5. I know I might have been using functions for the previous examples as well, but I hope you guys understood what I was doing and why I was doing it this way. Alrighty, so let's create another project, new project. Yep, there we go. So test problem 3, finish. Okay, now, which one should we take? And maybe it would be more efficient if I were to just do these problems before and then record myself, but actually this is a bit more challenging, so why not do it at the same time? This is boring, very boring. You've done this, and most of you have done it right, so I'm not gonna bother. No. Write a function to check if its parameter positive integer is a perfect square. Then apply this function to a vector of positive integers and extract all perfect squares and place them in another vector. Okay, so why not? Why the hell not? Okay, so 313. Write a function to check if its parameter positive integer is a perfect square. So let's just do that first. We need a positive integer, so okay, printf, please insert a positive integer n. Actually, yeah. Okay. So I'm not gonna check if that integer is positive. We've already done this before. Let's just assume that it's gonna be positive. So scanf, and actually I need an integer n, so scanf percentage d and n. Okay, and now what do? Write a function to check if its parameter is a perfect square. All right, that seems easy enough. So check if perfect square. No, actually I'm gonna name it int perfect square equals to is perfect square of n. Okay, so I don't have a Boolean type in this version of C, so I'm gonna use integers, and it's gonna be 0 if it's not a perfect square and 1 if it is a perfect square. So I will just copy this. So int is perfect square, and it accepts a int as a parameter. And how do I do this? Well, I think there are plenty of ways to check this, but I'm gonna need to include math.h and float sqrt equals to sqrt of n. And well, if let's just try this out. Return sqrt minus floor of sqrt equals to 0. So what I am saying here is that, well, if the square root of n is an integer, then subtracting it from the floor of that number should result to 0, and if it does, then this returns 1. If it doesn't, it returns, well, something else, not 1. I think it's -1. Let's sqrt is not a function. What? Oh, fine. Square root. Yep. Did I? Okay. So square root. Okay. Unused variable, that's fine. So if perfect square, then we will print out it is a perfect square. Else, just for the sake of printing out stuff, I will print out no. Okay, let's see. What? Printf. Good Lord. Okay, so let's try for 16. It is a perfect square, great, and 15 shouldn't be. 15 isn't. Okay, so this works fine. Now, what else does the problem want us to do? So, okay, so then apply this function to a vector of positive integers and extract all perfect squares and place them in another vector. Okay, that seems easy enough. So I will provide a vector of positive integers and apply this function to all of those values. And from that function, I will extract another vector which only contains the positive integers. Great, let's do that. Now, what? Okay, so I don't actually need this. But however, I will need the function which I created and then a vector of integers. So printf insert how many numbers you want, and well, yeah, n will be equal to that. So scanf n, should have left the code before. Okay, and then for I'll actually need to create a vector. So int vector vec, it's fine. Int star vec equals to malloc size of integer dot times n. So for int I equals to 0, I'm lower than n, I plus plus. I should just move this to a function, shouldn't I? Yeah, let's. So read vector, read integer vector of size n, and then integer star read integer vector of an integer n. And okay, I think this is correct. Let me just format it. And int n, no, int new n, and then scanf new n, and then vec of I should be equal to new n, and then I should be returning vec. Alrighty, should be fine. Hopefully I'm not missing anything. Let's try it out. Unused variable. Okay, this should be fine. So I've read the vector, and now I have to apply this is perfect square function for all the values in the vector and extract how many perfect squares I have. Interesting. I won't know how many of them there are. I will know, however, that there will be a maximum of n. So then I will need something like this. Int perfect squares equals to extract perfect squares from vector vec and n. I will need that n, definitely need that n. And this is an integer vector. extract perfect squares from vector, int star vec and int n. Okay, so these perfect squares will be inside a vector, so I will need to create that vector. Int star perfect squares equals to this thing. Okay, so that's the maximum size of the vector. And now for each element in vec, so from 0 to n, if is perfect square of vec of I, then perfect squares of, and I'm gonna need another variable, int j, so count perfect squares equals to 0, and this count perfect squares equals plus, why not, equals to sqrt of vec of I. And then I will return perfect squares. Interesting. Interesting, because now I will be tempted to iterate through this perfect squares vector until n, but actually I will maybe only need a few of them, and this helps. Okay, so I need to do things a bit differently, and because we haven't created and we haven't worked with structures yet, I can't use them, although I really would like to use a structure here. Instead, what should I be doing? So I have two choices here. First, I could be doing this. I could be actually passing this count perfect squares variable as a pointer from the main, and then use it as an output parameter. But I don't like that. I really don't like that. And what I'm going to do now is something slightly less efficient, but I think it's cleaner. I'm going to be doing this. Int perfect square count equals to get number of perfect squares from vec and n. So check this out. Int, and it's just an int, get number of perfect squares out of a vector and its size. And I'm gonna copy this code, and int number of perfect squares equals to 0. And if the number at position y is a perfect square, I will increment this plus and return this whole thing. Okay, now I got this, and now I can pass it here, which is the perfect square count, and it will accept another parameter. Let's be consistent. So number of perfect squares. Oopsie, I'm used to another shortcut. Okay, and this is called number of perfect squares. And now I know for a fact that I will only need number of perfect squares positions in that vector. Do I need this anymore? I do. I still need this. Okay, but now I can print that vector more easily. let's just format the code. Oh, much better. And print, actually, for int I equals to 0, I plus plus, I smaller than number of perfect squares. Printf v of actually perfect square of I equals to another integer, which is perfect squares of I. Okay. And I should just put a new tab here. Let's see what we've done. Statement with no effect. What? Oh, okay. What do you mean statement with no effect? Huh? Oh gosh, really? Did I just do that? I'm sorry. There we go. Okay, now it's fine. So how many numbers do you want? I want 10 numbers. Let's put in 8 and then 16 and then 5 and then 49, 121 and then 50 and 4 and 9 and 13 and 15. Okay, let's see what we got. So we got 4. According to this, it's 4. We should be getting, so 4, 7, 11, 2, 3, and that's it. 4, 7, 11, 2, and 3. Nice. Okay. Well, actually, I think it looks better with a new line. And I think this is too long, but I'm going to leave it like that. Again, we could be moving this to a function, but I mean, it's not really that bad. And that's about it. I think that's all it asked for, right? Okay, and extract all perfect squares and place them in another vector. That's what we did. Now, again, I want to reiterate this thing. So I know it's not as efficient. I sacrificed efficiency for code quality because here, in order to count the number of perfect squares I iterated through this vector once more, and I made sure that I got the number of perfect squares before I allocated these squares. Again, this could have been done easier with structures, but we'll learn that in the next lab. And well, yeah, this is the cleanest way, not the most efficient one, but I like it. If you would work like this, this would be fine. Alrighty, so let's go to the next lab. I brought up the pointers one, and well, I looked over the problems and some of them are maybe too long for this kind of thing, so I chose 3.9. Write a function to calculate the kth power of a square matrix using pointers to access the elements of the matrix. The resulted matrix shall be displayed as a bidimensional table. All right, so let's see how this should work. So first of all, I'm gonna be needing a function to read that square matrix. So first off, I'm gonna need an n, printf, please insert matrix dimension, and what am I doing? Oh gosh. Scanf, and that's the n. And then I will need a matrix. Read matrix, actually read square matrix of size n. And this function read square matrix, I'm gonna create that as well. So it returns a double pointer, which is a matrix. And let's just, this is just a lot of boilerplate code. Int matrix equals to int malloc size of int star times n, and then for int I equals to 0, I smaller than n, I plus plus, matrix of I equals to int star malloc size of int times n. And once we have this allocated, we need to actually read the values. And because we're at the pointers lab, let's not write this way. Let's write it like this, plus I. And we'll be using this notation throughout this problem just for the sake of following the instructions, because, well, here it asks us to use pointers to access the elements of the matrix. So no shorthand writing, I'm just going to use pointers. Okay, so for int I equals to 0, I smaller than n, I plus plus, and then the same thing for j, int j equals to 0, j smaller than n, j plus plus. Oh, great. Printf matrix of I and j, whoops, equals to, and this should be I and j, and scanf a number. Matrix of, oh gosh, matrix plus I, and then all this plus j, and I think that's fine. Is it? Yeah. Okay. And then let's make a function which doesn't return anything, but instead print square matrix, actually print matrix. Let's make it more generic. Int rows, int columns. Good Lord. What am I doing? There we go. So for, and I'm going to copy this because I'm going to need it. Okay. And also, why not this? Dum-da-da. No, I'm actually not going to do it this way. I am going to be doing it the easy way. I'm going to be printing the no, forgot about that. Matrix of I and j. Okay, and then here I want to print, no, yeah, now it's fine, and here a new line. Okay, so after reading this matrix, I want to also print the matrix and n. Am I still fine? Does this compile? No, of course not. Okay, so this should be rows and this should be columns. What expected? What am I missing? Huh. So something is wrong here. Yep. Now I got it. No, still no. Ah, this is extra. Compile. Non-void function, of course, and return matrix. Okay, now we're fine. Let's read a 4x4 matrix, and this is a 2, 4, 3, 6, 88, 44, 3, 1, 9, 4, 3, 5. Okay, so now it's 2, 4, 3, 6, 88, 44, 3, 1, 9, 4, 3. Okay, this looks fine. This looks fine. Okay, so I'm reading the matrix correctly, and I'm printing it out correctly as well. So I'll need a function to multiply two matrices. I'll be multiplying my matrix with itself, but I will need a more generic function to multiply two matrices. So how do we do that? Well, let's just create a function which will return a matrix, and let's name it multiply matrix. Actually, multiply square matrices, and I'm going to be multiplying matrix A, or first matrix, why not, with second matrix, and then I'll be using an n for that size. Okay, and now I need the result to be another matrix, and I would need to allocate a matrix again. So why not allocate square matrix? Why not make a function out of it? N. Okay, and then int square allocate square matrix, and this is the size, and I need this return matrix. Okay, formatting. Okay, and then I'll need this here, and instead of matrix I'll put result. Now as for the algorithm to multiply a matrix, it's not really that difficult. I think I need 3 for loops for this. So int I equals to 0, I smaller than n, I plus plus. And let's just copy this 2 more times. And this is going to be j. And this is going to be k. I think this is about right. So let's think a bit. So first off, I am gonna need a variable for that sum, which is the sum on the columns and rows. So let's put that in an integer, sum, and sum should be equal to what it was before plus first of I and j plus second of j and oopsie j and I think it's k. Yes, no, actually it's ij. No, this is wrong. This is ik, and then it should be k kj. Oh, it's been a while since I've done this. Let's hope it's fine. Ik and kj. I think this is fine. And then outside of this for loop, when this is done, the result of I and j should be sum, and also sum should be equal to 0 here, and then return result. So I might have gone wrong with the indices, but hopefully I'm not, and I didn't. Oh well, we'll check. And now what I need and what the problem actually asked me to do is to write a function to calculate the kth power of a square matrix. And then I will also need that k. So int k, printf, please insert k. Okay. And scanf dk. Oops, there we go. So now I'll need something like this for int, actually just create a function for this. Compute, so int result equals compute kth power of matrix, of square matrix. And I'm gonna put in the matrix and the k, and also the size. I'll also need the size of that matrix. Let's format the code, create this function, int compute kth power of square matrix, and I'm sending it the matrix. I'm sending it an n, which is a size, and a k, which is how many times I want it to compute it. Great. Now, for int, actually I'll need a result again, equals to, actually result should be equal to nothing right now. Let's just leave it at that. And then I need to iterate a few times, k times more exactly. Int I equals 0, I smaller than ki plus plus. And result should be equal to multiply square matrices of matrix n, but this actually should be matrix result n. So I need to copy all the values from matrix in that result such that I don't lose them. So that means I have to do something like this. Copy matrix matrix and the size. I don't think it would work if I were to do this. I'm pretty sure it wouldn't, and it's not recommended. So I'm just gonna create a copy. So copy matrix, and this should be like this. Okie dokie. So I need to allocate a square matrix again. And I'll copy this thingy. Actually. Okay, and result here. And instead of scanf, I will just need result of ij equals to matrix of ij. And then I'm returning the result. Great. And here I can use this. And more clearly this. Let's see if it works. First undeclared, what? First matrix, duh. Okay. Unused variable result. Oh, okay, so print matrix of result and n. I don't need this. And that's about it, right? To view, okay, because I need it twice. Okay, phew. So let's hope to God this works. N equals to 3, 1, 1, 1, 1, 1, 1, 1, 1, and then 5. How do we check if this is correct? I think Google will help. Matrix. So matrix multiplication online. Okay. Matrix power. Oh, this is even better. So matrix dimension should be 3 and power should be 5. Let's set the matrix to 1, 1, 1, 1, 1, 1. This is such a nifty tool. Calculate. God made it work. Oh no, I'm wrong. I'm definitely wrong. I'm off. Shoot. What did I do wrong? What did I do wrong? I'll pause it a bit and then come back to you. Okay, so I figured out one thing that was wrong. I didn't initialize sum here. Well, that's one thing, and now I get something like n equals to 3, 1, 1, 1, 1, 1, 1, 1, 1, 1. And for k equals to 4 or 5, doesn't matter, I get 600, but it's a bit off. And I know it's a bit off, but why is it off? I'll be back. All right, so now I got what I was missing. So besides this sum, which wasn't initialized, this should have been a times sign, not a plus. So I should be multiplying these, not addition. Okay, and now it's fine. Now it's fine. Alrighty, so let's just have the unit matrix, and the k should be 4, and now I'm getting 81. Which is, well, it's not, you know what, whatever. This should be 5, and this is if oh god damn it, just now it's fine. So 3 1 1 1 1 1 1 1 1 1 and k should be 5. Voila. Okay, that's it. That's it. Now it works, and my main function is clean. I have everything's, you know, in separate functions. Oh gosh, I forgot. I completely forgot. I should be using pointers. Fine. So instead of this first matrix of I, k, I should be using this plus I and this and plus k. And same thing for this little fellow, like this, plus k plus j. Okay, it's a bit confusing that there's this multiply sign here. Maybe it would help to have it like this. Gosh, please don't write things like this just for the sake of exercise. That's fine, but really it doesn't make sense. So here it's result plus I and plus j, and also matrix plus I and plus j. Okay, am I missing anything? Have I missed? Yes, I have. Matrix ij, I know I've written this before, so I'm gonna take it from here. Yes. Ta-da. Okay. No? What? No, it's not result, it's matrix, I know. And have I used, yes, result of ij equals to sum. There we go. Format. Now hopefully I've replaced all my, well, of course. Hopefully I've replaced all my square brackets with the pointer stuff, and it looks a lot uglier and it's not readable. But for the sake of the exercise, I did that as well. So n equals to 3. Let's make sure it works. And it does work. So yeah, there we go. Okay, next one is the last problem. I promise it's from the last lab and we'll be done. Thank you. You know what? I've actually looked through the problems in the last lab, number 9, the strings, and well, I've given you most of them as homework. And honestly, it doesn't make sense to just solve one, because the approach will be quite the same. So hopefully you guys understood how I think about these problems, how I create the functions and why I do them. Many times, one of the principles I use is, well, if I need something and it can be written as a function, I will just write it as a function. And well, hopefully you guys have seen this in everything I did. Even if I needed something very small and well, which occupied maybe 5 lines of code, I still took my time and wrote a function for it. My code is cleaner that way. I can read it more easily. Yes, in case of, for example, the second problem in which I had to calculate, the apparition vector, the frequency vector, you will see a lot of code which resembles itself. However, that's not the end of the world. These are example problems, and it's normal to have, a bit of duplicate code within, well, not within the functions, but between the functions themselves. In real life, you won't be required to write both an apparition vector and a frequency vector. Most likely, maybe you will, but nevertheless. But the approach should be just write as many functions as you can if it makes sense, and keep your main function as clean as possible. Make sure you have good naming conventions and good names for the variables and for the functions. And yeah, I think that's about it. If you guys have any questions, either post them in the comments or ask them at the lab. That's equally fine. And well, I wish you guys a nice week and see you in 2 weeks. So bye-bye.